In this particular video, we're going to have a discussion. We're going to look at how to answer questions to do with circular motion as far as year 13 physics is concerned. If you're new to Proflan, consider subscribing and also following us so that anytime I'm going to upload more tutorials, you'll be notified. So we're going to look into it and get to see how are you going to approach questions that are asked. So if you are asked to work out the angular displacement is given by the arc length divided by the radius of that particular circle where the object is moving in a circular path. Also, you also need to understand that 360 degrees is equals to 2 pi radians. And this is going to enable you to do the conversion of angles from degrees all the way to radians and from radians all the way to degrees. And exactly this is what we are going to use in the process of working out. Another important formula that is key in this particular topic is the use of angular speed. Angular speed is given by the formula 2 pi over t, also angular, because 1 over t is basically frequency. Then it means that also if you are given a question and they want you to work out the value of angular speed, you can be able to say angular speed is 2 pi f. Now in that case, if you are given the frequency, you can be able to work out that particular angular speed using that formula. That's also when an object is moving in a circular path, something that you need to remember is that this object is going to have what we call linear speed and also angular speed. So if you are finding linear speed, you will take the radius of that circular path times the angular speed. Linear speed is the speed at which the object is moving. So if you consider this object at this given point, it will be having angular speed, but also it will be having linear speed, which is acts in a tangent like that. So basically those are the formulas that we're going to study as far as circular motion is concerned. And also we shall be talking about angular centripetal acceleration. Centripetal acceleration is given by v squared over the radius, or it can be given by r omega squared. Finally, we have a force that keeps an object in a circular path, a force that is always directed to the center, and this type of force we call it centripetal force. In the event you are given a question and you are told that a metal wheel consists of an axle, 8 spokes and a rim shown below, then we are told that this particular object that you are having here is moving in a circular motion. Then we need to be able to find the speed, linear speed. And we say that linear speed is given by omega times what? Omega times the radius. Radius times the angular speed, you will be able to get the linear speed, which is going to be 0.85. You can see here the radius is 0.85 and the angular speed was given also in this particular question as 140 radians. Then in order to work out the speed, you are supposed to say speed, linear speed is radius times the angular speed, and then that is going to become that centripetal acceleration is given by angular speed squared times the radius, or linear speed squared over the radius. Now since we have gotten the linear speed here, we can be able to get the centripetal acceleration. Centripetal acceleration is going to be the linear speed that we have gotten here squared divided by the radius of this particular rim that we are talking about, and that is going to become 1.7 times 10 raised to power 4. But remember, in this case, you are taking the linear speed squared divided by the radius of this particular rim that we are talking about here. So basically, that's what you're going to do. This is going to be a question for the next part, so that you can be able to see how do you deal with questions which are circular motion questions inside a cone, because we are having a cone and then there is a ball that is moving in a circular path. So in our next session, that's exactly what we are going to look at. But the most aspects and the most important thing that we are talking in this particular lesson is that for you to work out questions to do with circular motion, you ought to understand different formulas that we have highlighted here. And we have said angular speed is calculated by this particular formula here, or you can be able to say angular speed is 2 pi f, or angular speed is equals to pi e. And also you can be able to say angular displacement is the arc length divided by the radius of that circular path. Also, don't forget the concept of linear speed, because an object which is moving in a circular path has linear speed and angular speed, and that is going to be equivalent to V is equals to RW. Now moving into the application bit of this kind of question, so that we can be able to see how you are going to answer a question. You are asked to define a radian. A radian, we are going to say radian is an angle subtended at the center when the arc length is equal to the radius of that particular circle. So we can be able to define it as an angle 1 radian, or a radian is an angle subtended. Let me just look for a pen that can be able to write properly, as we can be able to proceed. Here. Yeah, so this is going to be is an angle subtended at the center. When the arc length is equal to the radius. Yeah, so basically that's how you can be able to define 1 radian. Calculate the angular speed. We know that angular speed is equals to angular speed is calculated by the which formula? What did we say angular speed is equivalent to? Angular speed is basically 2 pi. Let me just show you here in this particular formula we mentioned. Angular speed is 2 pi over t, or 2 pi f. But in this particular question, we are told there is a speed here, right? So are we going to use this formula, or are we going to use this particular formula that is stated here? Yeah, all omega is equals to 2 pi f. Can we use that? Calculate the angular speed, and we know angular speed is equals to V over R in this case, right? Because from this particular formula that we have at this point, you can see V is equals to RW, or R omega. So if we are finding omega, it will be V over R, and that is going to be 17 divided by the radius. The radius of the rear wheel, What's the radius of the rear wheel in that case? We need to check the radius of the rear wheel. Let's check the radius of the rear wheel here, which is going to be 0.46. The radius of the rear wheel 0.46. If you work it out, you are going to put that in the calculator in order to get what the answer is. So we are going to say 17 divided by 0.46. If you work it out, you're going to get your answer equivalent to 36.9, which is approximately 37 rad per second. Yeah, so that becomes that. So basically, that's how you work out question to do with circular motion.